we are going to take in this session. So in introduction, we have like what is testing and why we need it. Then we have the test plan and the test strategy. Like what is test plan and what is test strategy, and where we use these two component of testing document, or you can say testing criteria. Then we have the different type of system testing. We will cover the validation and the verification part in this tutorial. We will see the different testing models in this session, like waterfall model and V model. So we will see what is these two models and where we need to implement these two models of our traditional testing. Then we will cover what is defect and what is the life cycle of a defect. Then we will see the SDLC and the SDLC. SDLC is software development life cycle, and the SDLC is software testing life cycle. So we will see what is these two components. We will also cover the priority and the severity part of the testing, and how we can see what is severity and what is priority, and why we need these two components when logging our defect. Then we will see the test case and what is the format of test case, and we will see the defect format also. After that, we will cover the agile methodology in testing and how it is important from testing point of view. So these are the topics we are going to cover in this complete tutorial. So testing session. In this session, we are going to see what is testing and why we need testing. Like what is the reason for testing a software or testing a product. So basically, software testing is an intent when we are executing any application or any product by automation tool, or you are doing it manually. So we should have some intent for our testing. So there are few reasons why we do testing for our product or for our application. Like first reason is find the defect in the application. So our main motive as a tester is to find more and more defect in the application, so that we can give the quality product to our clients, to our end user. The second reason is like we wanted to see if the application is behaving like whatever is supposed to do. My application is looking to add two number a plus b, so it should do the a and b, and result should be goes to the c. So our task is to test the application behavior, what is it supposed to do, and if that is working as expected or not. So this is our task, why we do our testing. We also verify the quality of the product or application. So behind the reason of a software testing, we have a motive to give quality of product. Like we wanted to give our end user a product which they can easily work and they don't have any issue while they are working on that particular software. The reason for like testing the application is also like we wanted to verify if the product or application is working correctly on a different operating system or different browser. So as a tester, we test our application on different operating system as well as on the different browser, so that we can say to our end user that you can work on this application on any environment, like different browsers like Chrome, IE, Firefox, Safari, or any operating system like Linux, or you can say Windows. So any operating system you can work, and it will work correctly on all the environment. We also do our testing for the client satisfaction, because on the basis of the development testing, like they do the unit testing, but they don't do the complete end-to-end testing. So for our client satisfaction, we do our testing. Few more reasons we have, like we have seen where the product or application meets the requirement, like we have a requirement document which client share to our development team, or you can say the testing team also. So we are looking for our application behavior on the basis of that requirement document. So this is tester's job to verify if the requirement document is matching with the application's behavior. We also wanted to validate the developer to develop what it is needed by the end user. Like if developer want to build a software on a particular requirement document, so as a tester we have a responsibility, like we should see if developer has developed as per that particular requirement. Then the reliability of the product, like the reliability of the product or application is also there. It will work on a any environment, or you can say for our future, you can say patches of your software. Then it is also important that the project plan which is shared to the client, because as a tester we give our sign off to our client, like we have tested this application or this product thoroughly and we have not seen any defect. So we give a document on the basis of our testing to our end user, or you can say end client. So this is the reason why we do our testing. We also do the testing to verify the software performance. Like we have different performance tool for testing the performance of the application. Like if I'm executing my application for one user, or let's say I'm executing my application for millions of users. So how you can validate that behavior should be exactly the same for different load when we are going to execute our application for multiple users. So this is the tester's responsibility to check the performance of the application to save the time and the money of the client, because like the client is investing some money and the time to create a software or a product. So that's why we need someone who can say like this is the software which is good for your requirement, like it is as per your requirement, like it will not going to crash when you will use this application on the real environment. So to save the time and the money of the client, we use to do the testing of the application or the product. Then we have to share the complete document to the client, because tester test the application after the all the phases that are completed, like the requirement gathering, the software development, then the software testing comes. So software testing is the phase where we share all the documents to the client, like this is the software what you need and we have developed in the same way. So all the document mentioned all the criteria which we have created. So we used to share the document to the client so that they can see like what he needs and what is developed. So these are the reasons why we do testing for our application or product. And this session we are going to see what is a test plan and how many types of test plan are there for our implementation. So let's see first what is a test plan. So basically a test plan is a document which describes the project plan, like which is needed to be executed for this project. Like we wanted to say like on the basis of this document we are going to execute our project from starting to end. Like we are saying like how we will start our testing and how we are going to finish our testing to submit the application, or you can say to give the application to the our client. It could be different from like project to project. So it is completely different from organization to organization or project to project, but there are few fields like which are similar for all the projects. Like we have few components of the test plan which is similar. We will see the component in our upcoming session. Like we need a test plan because it is a guide for our thinking. Like whatever we have written in this document, we are going to follow only these things. So why we need a test plan? Because it forces us to solve the problems. Like testing candidate have to take the challenges. Like if we are as a tester, we are going to test the application, then we should have a document, and document is a guideline. So it is a challenge to follow the guidelines. So we are ready to take a challenge on the basis of our test plan. And also test plan is important because we used to communicate to our project coordinators like our client, our developers, our other stakeholders on the basis of a test plan. Because once we create a test plan, then we send to this to our all the stakeholders, and once they approve this test plan, then we used to start our testing on the basis of this test plan. So this is important because it is a communication channel. On the basis of this we used to communicate to our different stakeholders. Test plan is also important because it is easy to maintain the changes, like in the later phase of your development, or you can say in the testing phase. If we wanted to change anything, we wanted to add any particular functionality, or we wanted to remove a particular functionality, then what we are going to do? We are going to document that change in this document. So test plan is also important because it is easy to maintain the changes what we are doing on the beginning of the project till the end of the project. So all the things are maintained in this document. So test plan is a very important document for all the testing projects, like it has all the necessary components on the basis of you start your testing. So let's see how many types of the test plan are there. So we have three types of test plan. Like we have master test plan. The master test plan is basically used to work with all the testing projects of our organization. So we have one test plan, that is our master test plan, that will take effect for all the projects. Then we have the testing level, specific test plan, like each level of testing. Let's say we have unit testing, we have integration testing, we have the system testing. So on the basis of your level of testing, we have a test plan. So on which level, or you can say on which type of testing you are going to perform which test plan. So it is completely depend on the testing label. So we have a certain document for our testing level specific test plan. So we follow these testing phases on that particular document basis. Then we have the testing type specific test plan, like what kind of testing you are doing. Like you are doing performance testing, you are doing functional testing, you are doing security testing, you are doing database testing. So what kind of testing you are doing? So on the basis of the type of your testing, we have a test plan. So we follow that test plan on the basis of our requirement. Like whatever testing type we are doing, we used to take that particular document and we used to do the testing on the basis of that document. So we have three type of test plan document, like master test plan, like the testing level test plan, and then testing type test plan. So we used to do our testing on the basis of our requirement using this document. So we will see all the components of these documents in our next session. In this session, what all are the test plan document components? So there are many components that can be included in a test plan, but we have the below test plan in this video. You can see like these are the important ones which should be there for every test plan. Like we should have a test plan identifier, right? Any particular ID you can say. So on the basis of that identifier, we use to find our test plan. Then the scope of the testing, like what should be the scope, like when we are going to start and when we are going to finish, and what will be our scope for this testing. Then we have the introduction. So in the starting part, we should have an introduction of our test plan. Then we have the reference, like what reference document we are following to create this project test plan, like any link or any particular document which has client share or our company reference document. So we have to write the reference of that particular document here in the test plan. Then the test items, like what you are going to test in this application, like which module you are going to test. So we will mention the test items in this particular component. Then we have the feature to be tested and the feature not to be tested. So in this document, we have a section where we have mentioned like what feature we are going to test and what feature we are not going to test, and that is out of scope for this testing. Then the approach of the testing, like what should be the approach for this testing, what we are going to do. Then the item pass and fail criteria. So this is the important one, because how and on the basis of what we are going to pass or fail any particular condition, like it is referring to any reference document like SRS or BRS, like system requirement document, business requirement document. So whatever we are referring, we should mention on the basis of that particular document, we are going to pass or we are going to fail a particular criteria. Then we have the suspension criteria or resumption requirement. Like on the basis of what you are going to suspend any particular criteria for certain amount of the time. Let's say this particular criteria or the feature is going to be the next cycle. So that we can write in this criteria, like how we will decide like what is in this cycle and what is in the next cycle. Then the test deliverables. So test deliverables are the documents like at the end of our testing what you are going to deliver to the client, like the test case, like the requirement document, test plan, test strategy, defect sheet, like all the documents which you are going to submit to the client after completing this module or after completing this testing. Then we have the estimate, like what estimates you have given to the client, like what would be the hour for testing, like how much is the manpower and how much is the hour for our testing this product or testing this application. Then we have the schedule. We should have schedule mentioned in the test plan, like when we are going to deliver what, like on the date we should mention like every 15th of the day we will deliver what. So the first cycle, the second cycle, the third cycle, the different cycles we will mention in the schedule section. Then the staffing and the training needs, like how many manpower we need and what would be the training need for testing this application. Like if that particular application require any specific tool, then our user should get a training on that particular tool. So what is the training need? So all these things we will mention in the test plan document. Then we have the responsibility. So responsibilities are mentioned by the manpower, like who is the manager, who is the lead, who all are the team members. So what all are the responsibility of these members. So this could be mentioned in the responsibilities section. Then we have the risk. So what is the risk of this testing, you can say. And if we don't able to complete our testing in this, you can say cycle, then what is the risk behind this? Then the assumptions and the dependencies. So what should be our assumptions and what should be our dependencies? Is there any dependency, any third party tool or any dependency to the different product? So all should be mentioned in the assumptions and the dependencies section. Then we have the approvals. So who is the authority to approve the testing? Like if I complete one cycle, so who will be the responsible person to complete that sign off? Like I have given the sign off, then my lead or the manager is the responsible person to give the approval. So who all are the authority to give the approval? So this is mentioned in the test plan document in the approval section. So in this section, we have seen what all are the test plan document components and what is those components and why we need these components. Thanks for watching this section. In this session, we are going to see what is test strategy. So the test strategy is a high level document which defines the testing phase of the organization. Like it has some standard rule for all the processes, all the documents, all the activities that should be followed for the each testing project. like it is a organization label document which should be provided to all the testing projects. Like this is our standard, and this is how we start our testing. We can take an example, like if we get any product or any application for the testing, you should decide like what is better to do the testing. Like we should do the black box testing, or we should do the white box testing, or if we can do both, then at what phase we are going to do the black box, and at what phase we are going to do the white box testing. So all these details are mentioned in the test strategy document. So basically, it is an organizational label document which has all the criteria mentioned, like how we start our testing for any project in the organization. It has some components, and we will see these components of the test strategy document in our next session. We are going to see the test strategy document components. So we have many components which is required for the testing strategy document, so that as a tester we should follow that document. So basically, test strategy is a document which is based on the organization to organization, but it has some fields or some component which are important for each organization, and they have these components in their testing strategy document. The first component is scope and objective. So in the test strategy document, we should have a scope and objective mentioned, which is necessary for each and every project of the application. Like what we usually do for our testing, what is the scope of the testing, and why we do testing for this project. What is the objective of this testing? It is mentioned in the test strategy document. Then we have the business issues. So if we have any business issues, let's say with our client, with our end user, then what is the criteria to resolve these issues, or how we can outcome from that situation. So this is mentioned in the business issues section of the test strategy document. Then we have the roles and responsibilities. The roles and responsibilities section of the test strategy document will compile the management roles and responsibilities for our project, like the lead, the manager, the senior manager, like who all are the responsible person for our testing, you can say, department. So all that names are mentioned in this document. The communication and the status reporting tool, like how you are going to communicate with the client, like through mail, through phone, through chat, like how you follow your client, like how you communicate with the client. And the status reporting, like how you give your status to the client, like you give on the phone itself, or you write mail every day, or you write mail weekly basis. So how you give your status of your project status to the client. So it is mentioned in the test strategy document, which is for the organization level. Then we have the test deliverables. So we have a set of standard test deliverables, like the test plan, the test case, the defect sheet. So what all are the documents which we should give to our end user? It is mandatory because it is mentioned in our test strategy document. Then we have the industry standard to follow. So in an industry, what is going on and what we should follow every time, like how we manipulate this document. So it is mentioned in this document that how the industry standard we used to follow. Like we have CMM level 5, CMM level 3, CMMI level 5, that is a maturity level of the company, or the any ISO certification. So how the industry standards we used to follow. This is mentioned in the test strategy document. Then we have the testing measurement and metrics. So how you measure your testing on the basis of any particular matrix, or you manually do your measurement, like any requirement traceability metric that we called it as RTM, or how you measure your testing effort, the test automation and tools, like what expertise we have, like we are good in our automation testing, so what testing tool our employees knows better, let's say Selenium, let's say SOAP UI, or for the performance testing we used to do load runner, JMeter, QTP tool. So what tool we have the expertise, like how we do our automation. So this is mentioned in the test strategy document of the company. Then we have the risk and mitigation. So if any risk comes, then what will happen? Like the disaster and the recovery, you can say. So if the product is failed, or you can say any earthquake or anything happens, or you can say mishappening, so what is the risk and what is the mitigation of that particular risk? So it is all mentioned in that particular document. Then the defect reporting and tracking. So how you are going to report the defect to the client. Like it is mentioned in Excel or any tool like Zira, Rally, Quality Center that we called as ALM or Spira. So any particular tool you are going to use for your defect reporting. This is all mentioned in this particular test strategy document. Then we have the change and configuration management. So if you wanted to change anything, if you want any configuration issue, then how you are going to take that. So who is the responsible person who can assist you? So this is all mentioned in the test strategy document. Then we have the training plan. So if any particular testing application require any expertise like which we don't have, so how we are going to take that training? Let's say we are going to take the training from the outside or different company to freelancer. So what is the training plan if we don't have any expertise in our testing tool or any testing criteria? So these all are mentioned in our test strategy document. So in this session, we have covered like what is test strategy document and what is mentioned in that particular document. Thanks for watching the session. We are going to see what is agile methodology and what is the component that are available in your agile methodology. So agile is a methodology that promotes continuous iteration of your development and testing throughout the software development life cycle of the project. So throughout the life cycle, you continue working on the development as well as the testing simultaneously. Both development and testing activities are concurrent, unlike the waterfall model. Like in the waterfall model, we are working starting with the development phase and we don't have any work for the testing profile. But in the agile model, the testing is performed side by side when the development is going on. So as in the agile model, it is working simultaneously, whereas in the waterfall model, earlier we have the testing phase which comes very late. So let's see what all are the components for the agile. So agile has the sprint planning. Sprint planning has the product backlog. What is the product backlog? So product backlog has all the features that need to be implemented to create a particular application. It has all the features. That is called it as a product backlog. Then we have the team structure and capabilities. Like we define certain team members. So ideally in the agile model, we have 5 to 7 members of the team that have 4 to 5 developers and 2 or 3 testers. Then we have the business conditions. So what is the condition of the business? Then we have the sprint. What is a sprint? Sprint is a cycle of a particular feature implementation. So sprint is, you can say, it is a 15-day cycle ideally, right? In the particular sprint, or you can say in a sprint cycle, we got certain features that we have to implement inside those 15 days. So sprint backlog. So sprint backlog is taken from the product backlog, where in the product backlog we have all the user stories, but in the sprint backlog we have only the features that has to implement in particular cycle. Then we have the sprint burn down chart. So in the sprint burn down chart, it says how many user stories has implemented and how much is left. So it gives you the user stories as well as the time duration. So what is left and what is done, that is shown in the sprint burn down chart. It could be 30 days plan, it could be 15 days plan. So it is completely depend on your project. Then we have the daily scrum meet. So there is one more criteria in the agile model, that we have a daily scrum meeting with the team, which has all the stakeholders like the business analyst, the developer, tester. It can have the client also, but that is not necessary. So it has a 15-minute meeting, like each and every person in the team would give you their status, like what he has done yesterday, what he has done today, and what he is doing today for this sprint, and where he has stuck, if he has any issues. Then we discuss the task with and impediments. Like impediments are the stuck points. Then the decision making. So decision making is with the business analyst, like the BA, the management, you can say. Then the sprint review meeting. So in the sprint review meeting, we says like what we have done good and how we are working for our sprint. Then the informal setup, and when it is required at the last, after completing the sprint, we have the sprint retrospective meeting. So a retrospective meeting has the process improvement, like what we have done good in this sprint, what we have done wrong in this sprint, and what we should improve for our upcoming sprint. So that is done in the retrospective meeting. Then the Scrum Master responsibility we discuss. Like what should be the responsibility of the Scrum Master in the upcoming sprint, where we are lacking and where we need to improve. Then the prioritize of the tasks and decisions for the next sprint. So this is the agile methodology chart in which we have the different points which we follow in our agile model. So let's see the agile model. We call this as a Scrum. Scrum is an agile development method which concentrates specifically on how to manage tasks within a team based on a development environment. So basically, as a Scrum is initiated from a rugby match, like where we have the 7 to 9 members and they are working for one task. It consists of 3 roles and their responsibilities, that are Scrum Master, Product Owner and Scrum Team. So Scrum Master is responsible for setting up the team, sprint meeting, remove all the obstacles like any impediments. Then we have the Product Owner. The Product Owner create the product backlog, what we need in this particular sprint, and he is responsible to deliver the functionality to the client for each iteration. Then we have the Scrum team. Scrum team includes the development, the testing team, the DBA team. So all the team is included in a particular Scrum team. So in a Scrum, we have 3 main characters like Scrum Master, the Product Owner and the Scrum team. So as seen in the chart, we have the product backlog. So what is the product backlog? This is a repository where the requirements are tracked with detail for number of requirements to be completed for each releases. So let's say we have 3 or 4 cycles. So each cycle has different user stories assigned from the product backlog. So we prioritize that user story and fix them in a sprint as per the requirement. So process follow the Scrum testing is like each iteration of a Scrum is known as a sprint. Then the product backlog is a list where all the details are entered to get endpoint. During each sprint, top item of the product backlog are selected and turned into the sprint backlog. Like it completely depends on the priority. We pick up a point, we pick up the user story from the product backlog and put that into the sprint backlog. Then we have the teamwork on the defined for the sprint. Then the team checks for the daily work. And at the end of the sprint, team deliver the product functionality and has the retrospective meeting for that particular completed sprint, like what we have done good, what we have done bad, and what we should do for our better sprint. So this is the agile model and certain points for the agile methodology which we used to follow in our real project. So in this session, we have seen the complete agile model and the points which is followed in the agile methodology. And we are going to see what all are the differences between our traditional model and the agile model. So let's start with the differences in these two models. In our traditional model, requirements are clear at the inception of the project. It means that when you are going to start your project, you are aware of the requirement. But in agile model, requirements are not clear, because when you started working on, there might be some changes in the requirement. So you don't have any clear vision about the requirement. It is decided at the runtime when you start working on the sprint or on that particular requirement. And also in the traditional model, We have limited communication, like you don't communicate very frequently with the client or with the management. But in agile model, we have more communication between our different stakeholders. It could be client, manager, test manager, or other team member. In our traditional model, we have already elaborated process that need to be followed in the same manner. But in agile, we have limited process. The fourth difference could be in between agile and traditional is the time consuming as they develop the complete product in a single cycle. So your cycle could be more time taking because it is started from the requirement gathering till the testing completes. So your testing and your development take more time because it is started from the requirement phase. But in agile model, it is an iterative model that allows to develop easy in a short span of time because we have 15 days cycle. So let's say our sprint is 15 days. So in that 15-day cycle, you have to develop your requirement and you have to test that also. In traditional model, we don't have any scrum call or standard call, but in agile, we have scrum call where we discuss what we have done yesterday, what we are doing today, and if we have any challenges. In traditional, no flexibility to change the requirement because the requirements are gathered at the starting of the project, so you cannot change the requirement very frequently. So there is no flexibility. But in agile, we are more flexible to change the requirement or any stage. Like we can change the requirement in between the sprint, before the sprint, at any time. The traditional model is time consuming to understand, develop, test, and defect fixing. But in agile, it saves a lot of time due to frequent communication between our different stakeholders, where we communicate our client directly, what is working on, where is the defect, and how much time it will take to fix those. Then in traditional model, testing happens only after the completion of development. So it is at the last stage because once the complete software is developed, then only we start our testing. So it takes a lot of time to reach the testing cycle. But in agile model, testing team works in parallel with the development team. Like what they are working on, we are simultaneously started working on our test cases, scenarios writing, automation script. So we are working on the same requirement which the development team is developing. And at the last, automation is not useful practice because in traditional model, you can only automate your project once the complete software development and the testing completes. But in traditional model, it was not available. Here in the agile model, we have the continuous automated testing which ensures better quality. So in agile, it is possible that you can automate your requirement parallelly while development team is developing the software. So these are the few differences or you can say few comparisons between agile and traditional model. So we should be knowing these differences so that we can tell these things in the interview or to our management what all are the differences and how we need to interact with them. Are going to see what is static testing and what is dynamic testing. So let's start with the static testing. Static testing is a software testing technique by which software is tested without using or you can say without executing the code. So basically we have a different type of static testing that is informal. We have the walkthroughs, we have the peer review, and we have the inspection. So these are the techniques by which static testing is performed. Like it is informal. You can verify with your colleagues. Walkthroughs. of your code, inspection of your code. So these are the techniques which is executed without using your code execution. So static analysis can be also done by tools like a variable with an undefined value. Like you have created a variable but you have not defined any value for that. Then we have the inconsistent interface between modules and components. We have also variable that is declared but it has never used, unreachable code or dead code, right? Any code that is not using in the application. Then we have the programming standard violations, like we should follow the rules of your coding. Like you should keep comments, you should keep proper line format. So these are standard you should follow. The security vulnerabilities, then the syntax violation. So what is the advantage of static testing? Like it is useful to find the weakness in the code. It is also conducted by trained software assurance developer who is fully understand code. It allows a quick turnaround for the defects. It is relatively fast if the automated tools are used. Automated tools can scan the entire code base. So all the files can be executed in one go. So you can use the features of your Maven. Automation testing tool can provide the mitigation recommendation. It also permits the weakness to be found earlier in the development phase, like in the cycle, and it could reduce the cost to fix that defect which can cause the failure of your application. Then there is some disadvantage of the static testing, like it is a time to consume if the code is conducted manually. It is a time consuming process. Automation tools do not support all the programming languages, like you are doing Java, .NET, or any other tool like Python. So there is no tool which can use to verify static testing, and there is not enough trained personnel for each and every tool. Automation tools can provide a false sense of a security that everything is being addressed. So that is also a disadvantage of static testing. Automation tool only as good as the rules they are using to scan with. The automation tools is used to perform a certain fixed path. It does not find the vulnerabilities introduced in the runtime environment. So static testing has some disadvantage as like on this screen. So let's see what is dynamic testing. Dynamic testing defines that it is a runtime vulnerabilities of a program. Automated tools provide the flexibility on what to scan for. It also allows for an analysis of an application in which you do not have access to the actual code. Then you have to permit your static code analysis finding to validate that. It can also conduct against any application. Dynamic testing can be performed to test your code to any application. And there are some disadvantages of the dynamic testing also, like automated tools provide a false sense to security, that is, everything is being addressed. Then the automated tool perform false positive and false negative scenarios. Automated tools are only as good as the rules they are using to scan with. and there are not enough trained personnel to thoroughly conduct the dynamic code analysis, as it is also similar with the static analysis which we have seen in our last slides. It is also more difficult to track the vulnerability back to the stack location in the code, taking longer time to fix the problem. So there are some disadvantages of the dynamic testing also. So what is the use of static testing? Static testing can start early in the life cycle so that early feedbacks give you the more issues in the earlier stage. So there is less effect on the later part when the actual testing is performed. Type of defects that are easier to find during the static testing are deviation from standard, missing requirement, design defect, non-maintainable code, and inconsistent interface specification. These are the testing which can be used to do for your static testing. Static testing contributes to the increased awareness of your quality issues. So these are the use of static testing which we do in our real environment. So in this session, we have seen the static testing, dynamic testing, and the advantage and the disadvantage of both kind of testing. In this session, we are going to see what is the web testing checklist and why we need manual testing and why we need automation testing. So let's start with the web testing checklist. So web testing checklist should include the functionality testing, usability testing, interface testing, compatibility testing, performance testing, and security testing. So we should test the functionality of your application. We should usability testing because how easy user can use this application. Interface, that is the GUI part. So we should verify the GUI of the application. We should verify the compatibility with the different operating system, different browser. We do some performance testing and we also do certain security testing of the application. So these are the main web testing checklist that we should do while testing our web application. So let's see the automation and what is the advantage of your automation testing. So test automation is a testing which is done by certain tools. It is basically done for the regression testing. So there are some advantage and disadvantage of automation tool. So let's start with the benefits. It is fast because we run through some automation tool. So that is why the automation testing is fast than the human users. Then it is repeatable. So tester can test how the website software reacts after repeated execution of the same operation. So once your script is ready, you can repeat your script with number of times. Then the reusability factor is there. You can reuse your scripts multiple times. Then it is reliable because a human tendency is like if you do certain testing each time you are doing 1+1, then there might some case due to some laziness you might get some issue or you can leave some issues. But the automation tool is more reliable than the human. So the reliability is there. Then we have the programmable. So if the tester also wanted to learn certain tools, so this is the programmable and tester can program some test that can be bring into the hidden information also. So there are some advantage of manual testing also. Manual testing is preferable for the product with short life cycle, like it is a cycle of 1 month, 2 months, so we don't need an automation tool. At that time, a manual testing is more preferred. Manual testing is preferred for the product that really has constant changes. So if your application interface is changing very frequently, then the manual testing is good enough. Manual testing also requires less time and expenses to begin productive manual testing because it doesn't require any skill, like a special skill, special tool to perform testing. So that is why manual testing is important, because you can start your testing without any particular tool or any particular special skill. Automation testing cannot replace human intuition, inference, and inductive reasoning. Right? On the UI, you have certain number of things, but on the automation front, you can test only one. So if you are testing manually, you can verify more things, more features. When automation testing, also the middle of your test and examine something that had not been previously considered. So in the automation testing, you cannot say if it is not considered, you lost run. But in the manual testing, you can start covering more scenarios. So the disadvantage of manual testing is it is certain tasks are difficult to do manually, not stimulating. You cannot reuse manual test because it is a human tendency. If you are executing one script, you cannot reuse that script because you have to execute again. But in the automation tool, you can execute that script any number of times. So there are some disadvantages for the manual testing. Then we have ad hoc testing. So what is ad hoc testing? Ad hoc testing is an informal and improvisational approach to assessing the product. In an ad hoc testing usually only conducted once unless a defect is found. So if you have found any defect, then only you do your ad hoc testing. Commonly used in the software development, ad hoc testing is performed without any particular plan. So ad hoc testing is not scripted, not documented. So when we should execute ad hoc testing? Ad hoc testing can be performed when there is a limited time to do exhaustive testing and usually performed after the formal test execution. Ad hoc testing will be effective only if the tester has in-depth understanding about the system. Like if the tester has good knowledge of the application, then only he found the bug in the application while doing the ad hoc testing. That requires certain good amount of knowledge on the application. The forms of ad hoc testing is like buddy testing, the pair testing, the monkey testing. So these are the types of your ad hoc testing. You can work with your different team members, your colleagues. So you can perform your ad hoc testing as per your need. So how you can make your ad hoc testing more effective? You can do some preparation, like what you will do in your testing, creating a rough idea, divide and rule, like you can break the system and found the defect, target the critical functionalities. So the main priority of the ad hoc testing is to verify if the major functionalities are working fine using tools. Documenting the findings. If you're documenting all the findings you have while executing the ad hoc testing, then it is good enough because that would help you in the next time. Then you have the test case design checking. how you design your test cases. Like we have the test case design technique, that is boundary value analysis, equivalence partitioning, design table testing, state transition diagram, and use case testing. In the boundary value analysis, we verify our test cases from the corner of your features. So let's say I have test certain numbers, let's say 1 to 10, so I will also verify 11 and 0 also, so that it takes the values from the corner. Then we have the equivalence partition. In the equivalence partition, we create certain tools, like we create some valid scenarios and we create certain invalid scenarios. And we do our testing based on that. Then we have the decision table. We create a table and based on that, we take our decision to test the application. Then we have the state transition. In the state transition, we change the state of the system and then verify the application. Then we have the use case. So use case is something like you have previously or tested this application. Now you are testing based on your previous use cases. The test cases design technique, as we have already covered, like we have the statement coverage, branch coverage, and the path coverage. We have also the error guessing and the exploratory testing. So these are the techniques for the white box testing, which we can follow using the statement coverage, branch coverage, and path coverage. In the error guessing, it is completely depend on the tester's experience, tester's knowledge. Then we have the exploratory testing. It is also based on the tester's knowledge and he can randomly test the application. So in this section, we have seen what is the design technique and how we can perform differently on the system. In this session, we will see what is quality assurance and what is quality control. So, the quality assurance is the function of software quality that assures that the standard and the processes and the procedures are appropriate for the project and are correctly implemented using different tools. But in the quality control, the function we test to verify if the quality of the project has followed with the standard processes and procedures and the project produces the required internal and external product. When statistical tools and techniques are applied to finished products, then they are called as statistical quality control and it comes under quality control. So let's see the differences between QA and QC. So QA is a process which deliberates on the providing assurance that the quality request will be achieved. But the QC is the process which deliberates on fulfilling the quality request. The quality assurance aim is to prevent the defects. The quality control aim is to identify and improve the defects. QA is the technique for managing the quality, but QC is the method to verify the quality. QA does not involve executing the program, but QC always involved in executing the program. All team members are responsible for QA, but testing team is only responsible for QC. So we can say QA is a verification and QC is a validation part. Also, QA means planning for doing a process, but QC means action for executing the planned process. Statistical technique used on QA is known as statistical process. But the statistical technique used on a QC is also known as statistical quality control. QA makes sure that you are doing the right thing, but QC makes sure the result of what you have done are what you are expecting. Quality assurance defines standards and methodologies to follow in the order to meet the customer requirement. But quality control ensures that the standards are followed while working on the product. QA is the process to create the deliverables, but QC is the process to verify that deliverables are correct. QA is responsible for full software development lifecycle, but QC is only responsible for testing lifecycle. So in this section, we have seen what is QA and what is QC and what is the difference between these two terminologies. Session, we are going to see what is a defect, that is a bug, and why software has the bug. Software bug is a failure or flaws in the program that produces the undesired output. It is an error that prevents the application from functioning as it should behave. So there are 15 top reasons for the software bugs that I have taken here, like we don't have proper communication. We have the software complexity. We have the programming errors. We have changed the requirement while working on a particular requirement in the module. The time process. Then we have the time pressure. So time pressure gives you the bug because you left certain small issues. Then poorly documented code. Software development tool is not available correctly. Then the obsolete automation scripts we are using. Then the lack of skilled tester. So if we have only freshers in the team, they might left with some issues. So we require certain freshers, some number of experienced candidates for our testing team. Then we don't have the proper setup for the testing environment. So that can leave certain issues. Then we have starting to write code or test cases without understanding the requirement clearly. So if we start writing our test cases without knowing the functionality, then there is a chance you would left with certain issues. Then the incorrect design document. Then we have the releasing software patches frequently without completing the software testing lifecycle. In this, like we are not tested any functionality, but that is released. Not providing training to the resources for the skill needed to test that particular functionality. And at the last, the important thing is we have not given time for the regression testing. So that can cause a defect in the application. So let's see what is a test script and what is a test environment. Test script is a software testing that has the instructions to perform system testing. There is a various mean for executing test script like manual testing and automation testing. So test scripts are used in automation testing. Sometimes a set of instructions is also used in manual testing. That is also called a test script, but it is better term for the test cases. Some scripting language used in the automated testing are like Perl, Python, Ruby, Unix. So there are many testing tools are also available for test environment like Qtp, Selenium. For the performance testing, we have LoadRunner, JMeter, SOAP UI. So we have different tools for our testing as a automation tool. So we have the test environment design. Factors to design test environments are if the test environment needs in order to take backup also, verify the network configuration, identify the required server operation system, database and other components, identify the number of license required by the test team. So this is the testing environment designing which we need for the testing. So test environment designing is including the environment configuration, like it should have IIS, MySQL, Windows should be operating system should be Windows or Linux, the browser should be IE or Firefox, what is the Java version 6, 7 or 8. So this is the test environment designing that we need for our testing a particular feature or testing for a particular project. So in this section, we have seen a different testing strategy like testing environment, how we can test a certain feature. In this session, we are going to see what is regression testing, what is retesting, and we will also see what is smoke testing and sanity testing. So let's start with the difference between regression testing and retesting. So regression testing is carried out to confirm whether a recent program or code change has not affected the existing functionality. Like if we have implemented a new functionality that should not impact the existing functionality. So this is we do in our regression testing. In the retesting, we have carried out to confirm if the test cases that has failed is final execution are passing after defects are fixed using the same steps. The purpose of the regression testing is that the new code changes should not have any side effect. The retesting is done on the basis of the defect fixes. The defect verification is not the part of your regression testing, but the defect verification is the part of your retesting. Regression testing is also known as a generic testing, but retesting is a planned testing. Regression testing is done by the past test cases, but the retesting is done only for the failed test cases. Regression testing is checks for unexpected side effects. Retesting makes sure that the original fault has been corrected. Regression testing is only done when there is any modification or any changes in the program. But retesting is executes a defect with same data and same environment with a different input with new build. But the steps and the environment would be same. Then in the regression testing, it can obtain from the functional specification. But test cases for the retesting cannot obtain from your any document. Like it cannot be obtained from your beginning of your testing, because retesting only done when you have certain failed test cases. So based on the project and availability, the resources in the regression testing can be carried out parallel. But in the retesting, it is carried out before the regression testing, because once the defect is fixed and you verify that the defect is fine, then only regression testing can be performed. In the regression testing, you can do the automation for your test cases, but in the retesting, you cannot automate the test cases. So let's start with the smoke testing. So in the smoke testing, we call it as also a software build testing. If you develop a simple application which consists only one source code file, you merely need to compile and link this with the file to produce the executable file. In the smoke testing, the test cases is chosen which cover the most important functionality of the system. The objective is not to perform exhaustive testing, but to verify that the critical functionalities of the system of the application should be working. So, for example of a smoke testing, verify that the application launches successfully and check that the GUI is responsive. Right? GUI is loading correctly, like the GUI is loading and it is responsive. Then the sanity testing. So sanity is done after receiving a software build. The smoke testing was done before receiving a particular build for the testing environment. That is done only in the development environment. But the sanity testing done in the testing environment, like after a build is created and you verify like whatever is the bug for that a build is deployed that has fixed and there is no further issue is introduced due to these fixed defects or these fixed changes. So if the sanity testing fails, the build is rejected by the testing team. The objective is not to verify thoroughly the new functionality, but to determine that the developers have applied some rationality while producing the software. For example, if you are a scientific calculator gives the result 2 plus 2 is equal to 5, then there is no point testing the advanced functionality like 30 plus cos 50. So if a simple term is not working, so you cannot test your complex functionalities. So let's take a difference of smoke testing and sanity testing. Smoke testing is performed to ascertain that the critical functionality of the program is working fine. But the sanity testing is done to check the new functionality or the bug has been fixed. The objective of this smoke testing is to verify the stability of the system, and the objective of the sanity testing is the rationality of the system. Smoke testing is performed by developer or tester. Both can perform smoke testing, but sanity testing is usually done by the tester only. Smoke testing is basically a documented, but sanity testing is usually not documented because we verify if whatever is the new changes, the new defects that has fixed is working fine. Smoke testing is subset of regression testing, but sanity testing is subset of acceptance testing. Smoke testing exercises the entire system from end to end, but sanity testing exercises only the particular component of the entire system. Smoke testing is like general health checkup, but sanity testing is like a specialized health checkup. So these are the main differences between smoke testing and sanity testing. So in this session, we have seen the regression testing and retesting and smoke testing and sanity testing.